Integration. Integration is the reverse process of differentiation. If dy dx equal to f of x defines the gradient of a curve at a point, we integrate f of x with respect to x in order to find the curve whose gradient is f of x. The symbol integral denotes integration of. Thus, integral f of x means integration of f of x with respect to x. Rules of integration. If y is a function of x, the integral of y dx means the integral of y with respect to x. If y equal to ax to the power n, then the integral of y dx, meaning the integral ax to the power n, is equal to ax to the power n plus 1 over n plus 1 plus c, where a, n, and c are constants and n is not equal to -1. In particular, c is called a constant of integration. Examples. Integrate the following with respect to x. We have y equal to 3x squared and y equal to 3x minus 4. So what we are going to do is to say y equal to 3x squared, then the integral of y dx, where there's y, we replace our 3x squared. We are going to add power 2 plus 1 and then divide by 2 plus 1. So we are going to say the integral of 3x squared dx is equal to 3x to the power 2 plus 1 over 2 plus 1 plus c. So we are going to get a denominator 3. When we divide 3 into 3, we'll get a 1. So we are going to say 3x cubed over 3 plus c, which is going to give us x cubed plus c. Part B. Y equal to 3x minus 4. We are going to say y equal to 3x minus 4. We are finding the integral of y dx. Where there's that y, we'll replace our 3x minus 4. So what we are going to do is to add 1 plus 1 to the power x and then divide by 1 plus 1. And then we introduce an x where there's a -4. So we are going to say 3x to the power 1 plus 1 over 1 plus 1 minus 4x to the power 0 plus 1 over 0 plus 1 plus c, which is going to give us 3x squared over 2 minus 4x plus c. Definite integrals. If f of x is the function which is to be integrated for values of x from a to b, then the theorem states that the integral of f of x dx with limits from a to b is equal to f of x plus c is equal to f of b minus f of a. Note that in any definite integral, the constant of integration vanishes. So when you are given limits, the value of c, which is the constant, vanishes. Examples. Evaluate each of the following. We have the integral 3x squared plus 4x dx with limits 1 to 3, and the integral 2x minus 3 dx with limits -1 to 2. We'll start with the first one. We are going to say the integral of 3x squared plus 4x dx is the same as, where there's that power 2, we'll add a 1 over 2 plus 1, and then we are going to say 4x to the power 1 plus 1 over a 1 plus 1. It will look like that. We are going to say 3x to the power 2 plus 1 over 2 plus 1 plus 4x to the power 1 plus 1 over 1 plus 1 with limits from 1 to 3. From there, we are going to get our denominator 3 and the denominator 2. So we can always divide 3 into 3 to give us a 1. 2 into 4 will give us a 2. So which is going to give us x to the power 3 plus 2x squared with limits 3 to 1. So from there, we are going to replace a 3 where there's x, and then we'll subtract with a 1 where there's x. So we are going to say 3 to the power 3 plus 2 to the power 3 squared minus 1 to the power 3 plus 2 to the power 1 squared. So when we multiply 3 by itself 3 times, we'll get a 27. 2 times 9 will give us 18. 1 to the power 3 is a 1. 2 times 1 squared is the same as a 2. We are going to say 27 plus 18 minus 1 plus 2. 27 plus 18 will give us a 45. 45 minus 3 will give us a 42. We go to part B. Evaluate the integral 2x minus 3 dx with limits -1 to 2. So we are going to say 2x to the power 1 plus 1 over 1 plus 1. And then we are going to introduce an x where there's a -3. So we are going to say 2x to the power 1 plus 1 over 1 plus 1 minus 3 x to the power 0 plus 1 over 0 plus 1 with limits from -1 to 2. From there, we are going to get 2x squared over 2 minus 3x to the power 1 over 1. So if you divide 2 into 2, you get a 1. Will remain with x squared. So we are going to say x squared minus 3x with limits 2 to -1. So we are going to replace a 2 where there's x, and then we'll subtract by replacing a -1 where there's x. So we are going to say 2 squared minus 3, open your bracket 2, close your bracket, minus -1 squared minus 3 times -1. So that is going to give us 4 minus 6 minus 1 plus 3. So 4 minus 6 will give us a -2. 1 plus 3 is giving us a 4. And then we have a negative, so we have -2 minus 4, which will give us a -6. Like that. (2019). The gradient function of a curve is y equal to 6x plus 8. Find the equation of the curve passing through the point 1, 2. The gradient function of a curve is y equal to 6x plus 8. Find the equation of the curve passing through the point 1, 2. So what we are going to do is to integrate. We are going to say the integral of 6x plus 8 dx is the same as 6x to the power 1 plus 1 over 1 plus 1 plus 8 x to the power 0 plus 1 over 0 plus 1 plus our constant c. So we are going to get 6x squared over 2 plus 8x to the power 1 over 1 plus our constant c. Divide 2 into 6, you get a 3. So we are going to say y equal to 3x squared plus 8x plus c. At the point 1, 2, we are going to replace a 2 where there's y and a 1 where there's x, so that we solve for our constant c. So we are going to say 2 equal to 3, 1 squared plus 8 times 1 plus c, which is going to give us 3 plus 8, which is giving us 11. we'll transpose, we'll move the 11 from the right to the left. It will become a negative 2 minus 11 will give us a negative 9. Therefore, our constant C is equal to negative 9. Then the equation is saying the gradient function of a curve is given by y equal to 6x plus 8. Find the equation of the curve passing through the point 1, 2. Therefore, since we found our C as a negative 9, we are going to say our y is equal to 3x squared plus 8x minus 9. From this original integral, we found y equal to 3x squared plus 8x plus c. Replace a negative 9 where there's that c. So our y will be equal to 3x squared plus 8x minus 9. 2020. The gradient function of a curve is 3x plus 2. Find the equation of the curve through the point 1, 2. The gradient function of a curve is 3x plus 2. Find the equation of the curve through the point 1, 2. This question is almost the same as the one we have just looked at. So we are going to say the integral of 3x plus 2 dx is the same as, we'll add the power for x, which is a 1 plus 1 over 1 plus 1, plus we'll introduce an x where there's that 2, plus our constant c. So we are going to say the integral of 3x plus 2 dx is the same as 3x to the power 1 plus 1 over 1 plus 1 plus 2x to the power 0 plus 1 over 0 plus 1 plus our constant c. So we are going to say 3x squared over 2 plus 2x to the power 1 over 1 plus c, which is going to give us 3 over 2 x squared plus 2x plus c. Now, since we have been given the point 1, 2, we can always find the value of our constant c by replacing a 2 where there's y and replacing a 1 where there's x. So we are going to say y equal to 3 over 2x squared plus 2x plus c. At the point 1, 2, that's going to give us 2 equal to 3 over 2, 1 squared plus 2 times 1 plus c. So we are going to say 2 equal to 7 over 2 plus c. Then we are going to group the like terms together. Solve that common fraction. 2 is the same as 2 over 1. Common denominator 2. 1 into 2 will give us a 2. 2 times 2 will give us a 4. When you subtract 4 minus 7, you get a negative 3. So our c is equal to negative 3 over 2. So the equation of the curve is y equal to 3 over 2x squared plus 2x plus, where there's our c, we'll replace our negative 3 over 2. Therefore, the equation of the curve is y equal to 3 over 2x squared plus 2x minus 3 over 2. As simple as that.